This is the Indian CBSE question from Mathematics 2002. It says we should integrate 1 over the root of x plus 3 minus the root of x plus 2 with respect to x. To do this, let us begin right away. Alright, how do we work this out? First of all, a skill that's going to help me here is the skill of rationalization of sort. So I am going to rationalize the denominator. Okay, rationalize the denominator. And when I do that, this is evidently going to be multiplying the denominator, which is 1 all over the root of x plus 3, the root of x plus 3 minus the root of x plus 2. I'm going to be multiplying both the numerator and the denominator in this function with the opposite signed denominator, which is x plus 3. Instead of minus, now is going to be plus root of x plus 2 divided by exactly the same, divided by the root of x plus 3 plus the root of x plus 2. The brain behind this is the same brain behind equivalent fraction. This is just like multiplying it by 1, but it has a lot of effect. Okay, so when we simplify this rationalization, we are left with the root of x plus 3 plus the root of x plus 2 all over 1, because when you simplify this denominator, you are going to find that it's exactly 1. Okay, so it means that this is the function we now have. If I further simplify this to suit into my integral question, this will be x plus 3, raise this to the power of half, plus x plus 2, raise this also to the power of half. So I'm going to substitute what I've just gotten so far into the problem we are given to solve. And when that is done, the problem is going to be rewritten like this. It's going to be to integrate x plus 3 raise it to the power of half plus x plus 2 raised to the power of half. All are going to be integrated with respect to x. So when this is the case, remember the rule of addition of function integrals. So what this involves me to do is to integrate partly x plus 3 to the power of half. This is with respect to x, and add the integral of the other function x plus 2 raised to the power of half with respect to x. Having reached this level, now let us work it out. So to do that, I'm going to let u represent x plus 3, so that if I differentiate u with respect to x, that gives me 1. And in that case, the x will be exactly the same thing as the u. So when this is substituted into my integral function, the bracket x plus 3 close the bracket raised to the power half becomes u raised to the power half with respect to the u. And when we do exactly the same thing to the second function, this is also going to be the same thing as integrating u to the power of half also with respect to du. Okay, since we've reached this level, now let us integrate. If I integrate this function, this is going to give me exactly 2u raised to the power of 3 over 2. Everything is all over 3 plus a constant. Then add, when this is differentiated again, is going to be exactly the same thing as 2 all over 3 u raised to power 3 over 2 exactly plus a constant c. If I factor out 2 over 3 in the bracket, I'll be left with, open a bracket, u to the power of 3 over 2 plus u also to the power of 3 over 2, all at a constant. Remember, there's always a constant to it. Okay, so plus the constant c. All right, so let's simplify this. the first U represents something different and the second U represents something different, so we can put them together. Don't forget that. Okay, so this is going to be 2 over 3, open a bracket. Your first U represents x plus 3, so this is x plus 3 to the power of 3 over 2, plus our second U represents x plus 2, x plus 2 raised to the power of 3 over 2, all of them plus a constant c. Alright, since we've reached this stage, I can choose to leave this as my final answer, or I can simplify it by opening up the bracket, and that's going to give me 2 all over 3 of x plus 3, close the bracket, raised to the power 3 over 2, plus the same 2 over 3 again, into x plus 2, close the bracket, raised to the power 3 over 2, plus c. This is my final answer for solving this integral question given right above here. Did you understand the solution set? Let us know what you think in the comment section below.